In today's lesson, we'll be learning the method of elimination. In our first example, we want to solve the linear system by elimination. We first want to arrange the two equations so that like terms are aligned. My first equation is 3x plus y equals 19, while my second equation is 4x minus y equals 2. As you can see, like terms are already aligned. 3x is above 4x, positive y is above negative y, and 19 is above 2. Next, we want to choose the variable we want to eliminate. I'm going to arbitrarily choose to eliminate the variable of y. If necessary, multiply one or both equations by a value so that they have the same or opposite coefficient in front of the variable you want to eliminate. Let's begin by rewriting our equations. 3x plus y equals 19, and 4x minus y equals 2. Fortunately for us, all of the like terms were already aligned. We arbitrarily decided to eliminate the variable of y. If you take a close look at the terms containing y, the coefficient here is positive 1 and the coefficient here is negative 1. Remember, we wanted these terms to have the same coefficient or opposite coefficient, and here we have opposite coefficients. Next, we need to add or subtract as needed to eliminate one variable. Let's first label our two equations. I'm going to label this equation 1 and that equation 2. You have a choice to make. You can either add or subtract. I'm going to show you what happens in either case. Let's begin by rewriting our equations. 3x plus y equals 19 and 4x minus y equals 2. That was equation 1. That was equation 2. I'm going to add them. So 3x plus 4x is 7x. Positive y plus negative y cancels out. And 19 plus 2 is 21. Therefore, we have successfully eliminated a variable, the variable of y. If you had subtracted these two equations, you would have gotten something entirely different. I'm going to show you. 3x plus y equals 19, and 4x minus y equals 2. Again, that is equation 1, equation 2. We're going to subtract these two equations. So 3x subtract 4x is negative x. Positive y subtract negative y is positive 2y. And 19 subtract 2 is 17. As you can see, we have not successfully eliminated our variable of y. Therefore, subtracting would not be a good idea for this particular situation. Next, we want to solve for the remaining variable. If you recall, when we added these two equations, we ended up with 7x is equal to 21. Therefore, we need to isolate x, but x is stuck with a multiply by 7. To get rid of the multiply by 7, you need to divide both sides of the equation by 7. So those 7's cancel out, and you're left with 21 divided by 7, which is 3. Therefore, we have just solved for x, and x is equal to 3. Next, we want to substitute into one of the original equations to find the value of the other variable. Since I already know that x is equal to 3, I can substitute that into either equation 1 or equation 2 and solve for y. I'm going to choose to sub x is equal to 3 into equation 1. Let's start with 3x plus y equals 19. Instead of writing x, I'm going to write 3 in brackets, and everything else stays the same. So the plus y and 19 stay the same. 3 times 3 is 9. Everything else stays the same. If we want to isolate y, I need to get rid of this plus 9. To get rid of plus 9, I need to do the opposite to both sides of the equation. which means I have to subtract 9 from both sides of the equation. So that cancels out. I'm left with just y, and 19 subtract 9 is 10. Therefore, I've just solved for y, and y is equal to 10. Let's sum this up with a concluding statement. Therefore, the solution, or point of intersection, is 3, 10. We know the solution to the linear system is 310. However, we need to check to see if this is correct. Therefore, we need to substitute this point into both equations and do a left side, right side check. So I'm going to say sub 310 into equation 1. Equation 1 is 3x plus y equals 19. Instead of writing x, I'm going to put 3 in brackets. And instead of writing y, I'm going to write 10 in brackets. Everything else stays the same. I'm going to simplify the left side of the equation. So 3 times 3 is 9. 9 plus 10 is 19. Therefore, you can plainly see that left side is equal to right side. Therefore, this point lies on that line. I'm going to do the exact same thing for equation 2. I'm going to say sub 310 into equation 2. Equation 2 is 4x minus y equal 2. So instead of writing x, I'm going to write 3 in brackets. And instead of writing y, I'm going to write 10 in brackets. And everything else stays the same. So let's simplify this. 4 times 3 is 12. And 12 minus 10 is 2. Therefore, you can plainly see that the left side of the equation is equal to the right side of the equation. Therefore, this point lies on that line. Although this question wasn't really a word problem, I'm still going to write a concluding statement. Since left side was equal to right side for equation 1 and equation 2, therefore 310 is indeed the solution to this linear system.